All right. I hope you guys had a good discussion with those questions. Glycolysis occurred in the cytoplasm. What do we want to get at? We want to get at those high energy electrons and hydrogens, and we want to nibble at them in glucose. And the mobile carriers were NADH and FADH2. So hopefully you guys got a good little bit of practice time there. So let's dive into Krebs cycle a little bit. And just so you know, part of why students don't like it, and thankfully we're not going to get into that much detail, but part of the reason why a lot of students don't like it is if you truly had to know it all, it's nuts. It's crazy. But we don't have to know it all. I want to show you the main ideas. And again, the Krebs cycle is in the matrix. This is occurring on the very, very inner part of the mitochondria. And the goal, again, is to just keep nibbling and getting those high energy. Are you sick of me saying that yet? I bet you are. But we're going to grab those high energy electrons and hydrogens, and we're going to start stockpiling our NADH dump trucks and our FADH2 bulldozers. And so that is the main goal for our Krebs cycle. Now, before we fully go into the Krebs cycle, you need to understand there's kind of this weird little half step. And the half step is you're going to start with that pyruvate. Now, just a quick refresher, pyruvate was the end product of glycolysis. And we're going to take that pyruvate and convert it to another molecule called acetyl-CoA. And as we do that, we're going to be able to get a carbon dioxide. Hey, that's right. Carbon dioxide was one of our products. What? Okay, so Krebs cycle is producing the carbon dioxide. And that conversion process is kind of right before the Krebs cycle. So one carbon dioxide is released. We also can make another NADH from it. So we're starting to pile these guys up. And we got to start like keeping count. And we're going to do that on the right-hand side here. Now the Krebs cycle is just going to continue. It's just going to grab some more electrons and make a stockpile. We've got this whole convoy of NADH dump trucks with our high energy electrons and FADH FADH2 bulldozers carrying more electrons and hydrogens. And in the process, we're going to break 2 carbon dioxide off. And we can make one lowly ATP there, not a lot. Now, there's something very interesting that we need to keep track of, and that is this is just one pyruvate. For all of you that love to be like really detail oriented, you'll love this because you're going to be that kind of person that's like, hey, yeah, don't you remember? She said it's only one pyruvate. So for others that may not be as detail oriented, this is going to drive you nuts. But I made it in a nice list for you. It should be nice and easy to practice. So we just did this for one pyruvate. But notice, if we need to keep accounting, there's actually 2 pyruvate. So everything we do has to be multiplied by 2. So over on the right, that's what I did. Let me go ahead and present this to make this nice and bigger here. So over on the right, what you're going to notice is everything is multiplied by 2. So in the step where we convert pyruvate to acetyl-CoA, 1 CO2 is released. But because we do it for 2 pyruvates, we actually get 2 carbon dioxides. Now, if we do this correctly, we should end up with 6 carbon dioxides. Because remember, that was our equation at the very beginning, 6 carbon dioxide. So you keep me honest here. You watch. Let's see if we do this. So for 1 pyruvate in the conversion, we can get 1 NADH. But that happens again with the other pyruvate. So that means we need to account for 2. And we're going to practice this. So again, if you're kind of getting this, if you're looking like him, don't worry, we're going to practice. All right. So the Krebs cycle is going to be able to make 3 NADH, 1 FADH2, and 1 ATP. But again, that's just for 1 pyruvate. We got to multiply by 2. So 6 NADH, 2 ATP, and 2 FADH2, and 4 carbon dioxide. So all you bright mathematical people, let's add them up. So here's my bright green plus sign. So we've got 2 carbon dioxide, 4 carbon dioxide. So go ahead as a class and you guys decide. You should have gotten 6 carbon dioxides. Hey! So, we were right, 6 carbon dioxide. So what about the NADH? We've got 2 NADH and then 6 NADH here. So that means we can get 8 NADH. And remember, these guys are going to be our sneaky character that like ends up being a huge role here. So we've got 2 ATP, so we can just move that down. We just have 2 ATP. And then 2 carbon dioxide. Oh, I already did carbon dioxide. Sorry. 2 FADH2. I'm forgetting my accounting here, guys. So let's go ahead and fill this in. So we've got 2 ATP, 8 NADH, 2 FADH2, and 6 carbon dioxides. That is ultimately the job, the products of both our conversion step and our Krebs cycle together. And so that ends up being really key, like what is going to go on with them? You know, here we have our big convoy of these guys. What's the big deal with them? Now, just to show this visually, I found, here's, sorry, I did not mean to skip this. Again, you don't need to know this diagram. You certainly don't need to know the one on the left. That's nuts, right? I don't even know this one. I know it because of the Krebs cycle, but I don't know all of these molecules. But I included it because you can at least notice, okay, there's where the carbon dioxide comes out. And we strip, and you can actually count it up. 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5. Oh, we lost a carbon as carbon dioxide. And then we do this again, we lose another carbon dioxide. This is another cycle where we start with a 4 carbon molecule and we join the acetyl-CoA to get a 6 carbon molecule. And notice that's called citrate, so this is also called the citric acid cycle. And this just keeps happening and happening as long as we have our beginning molecule, acetyl-CoA, and this is going to be kind of interesting, as long as we've got empty NADs and FAD, as long as we have empty dump trucks and empty bulldozers, we can still keep going. But what we can look at a shortened version. Here's our pyruvate from glycolysis. That gets broken down to acetyl-CoA. We lose a carbon dioxide. We can make a NADH, and that was in our previous slide. And then we have the Krebs cycle where we can get 2 more carbon dioxide, 3 more NADH, an ATP, and an FADH2. Again, we're nibbling. Don't forget about our goal. We're nibbling away at the electrons. But remember, that's just one pyruvate. So we got to do this again. So that's where 1 carbon dioxide plus 2, that's 3. But then we have to do it again. 4 carbon dioxide, 5, 6. 1 NADH from the conversion, 3 more, that makes 4. Then we do it again to get 8. And so that's showing the cycle happening. We do it twice to get FADH2. We do the Krebs cycle twice to get 2 ATP. Now, this is a more visual interpretation of what's happened so far. And I was happy to find this because it does show everything visually. So remember, glycolysis is happening in the cytoplasm. So this right here is the cytoplasm. Here we have the mitochondria in kind of gray. So let's go ahead and go through what we have so far. we took glucose and started the process, and we get 2 pyruvate and 2 2 ATP. And they don't have NADH here, but we should add it. By tomorrow, I'll probably have this in here, so 2 NADH. Notice what I did for this diagram is I have, two sets of these. So you can see now what's happening with each. So 1 pyruvate gets converted to acetyl-CoA, goes to the Krebs cycle, and here we go. We have 1 NADH and 3 NADH and 1 ATP. And then this pyruvate can do the same thing. 1 acetyl-CoA to the Krebs cycle, and we get 1 NADH here, 3 NADH, and notice they all add up to what we did. 1, and then that would be 4, 5, and that would be 8. 1 and 2, that gives you 2 FADH2. 1 ATP and 2 ATP only gives us 2 ATP. We don't have the carbon dioxide in this diagram, but we're looking at our convoy right now. And then we have our electron transport chain, which we want to talk about next, but we'll probably be doing that next week. So that gives you a nice visual, and then we're going to practice on our Jamboard. So I hope that gives you at least a starting point. But don't worry, you are in good company, because there are a lot of memes that people make about the Krebs cycle. And we're just doing a very, very basic approach of what's happening. So, but just had to give you a giggle a little bit for that. So, all right, so that's our Krebs cycle little video lesson. Now we're going to practice in our Jamboard.